All right, so DNS Exam 1 problem number 24 was interesting, and I thought I'd rather do this one live with you guys rather than talk through it here. So we've been given g of x defined as the definite integral of another function, f of t, starting at 1 and ending at x. And I tried to graph this thing over here and then realized my graph had a lot of inaccuracies. So we're just going to ignore that graph right here and try to look at this one, which looks a little bit more like what it was actually supposed to be in the book itself. So something like that. The interesting thing about these problems is to realize that that lower limit of integration is fixed at 1. So I'm going to kind of draw a little dotted vertical line right here. That's the line right there, x equals 1, at which we're going to start measuring this thing for the net area between the curve, which is f of t, and the x-axis, starting at 1 and ending at whatever our random x value is. So what they were asking us to do in this problem was not necessarily to find these four values right here, but simply to make a statement comparing their size. So if we look at our four answers, if you haven't seen them already, it's just a hierarchy problem, which you'll see once in a while on an AP test, asking you to figure out which one is the least and the greatest and everything in between. So we might be able to come up with definitive answers for a few of these, maybe not for all of them, but we should be able to figure out how they all relate to one another. Now, since we're talking area, it probably would be a good idea if we took just a moment and figured out some of the individual areas here between this curve and the x-axis. So if I drop this vertical line right here at x equals -4, we have a 2 by 2 right triangle. That one is going to have an area of 2, 1/2 times base times height. We've got a triangle right here on the bottom that goes from -2 to +1, so a base of 3 and a height of 1. So 1/2 times 3 times 1 is going to get us a 1.5 for the area of that triangle, but of course notice that's below the x-axis. And then we have a big triangle over here from 1 to 5 with a base of 4 and a height of 1, so that triangle's area is going to be 2 as well. Okay, so armed with that information, let's take a look at the four things we're being asked to find. These x values, -4, -2, 1, and 5, are what would go right in here into this integral for f of t. So I actually want to start with this one right here, the easiest, g of 1. G of 1 would be an integral from 1 to 1 of, who cares, an integral from 1 to 1, same limit, is always going to be 0. So that's one that we know for a fact. Out of the other three, I think probably the easiest one to measure next would be g of 5. If we were to put a 5 here for the upper limit of integration, we're measuring the area between this curve and the x-axis, starting right here at 1 and ending right here at 5. Now those limits of integration are going to be in the proper order. The lower limit, the left-hand limit on the bottom, which is 1, and the bigger limit, the right-hand limit of 5 on the top. So that area, because it's above the x-axis, means that that value is going to be exactly 2. Now, as we move backwards here from where we are at x equals 1 to a -2, okay, from 1 to -2, which is this line right here, we already measured that area at 1.5. Now, since that region is below the x-axis, it's tempting to make that a -1.5. But the thing to remember right there is that g of -2 would actually be an integral starting at 1 and ending at -2. Those limits are backwards, which means this answer is actually going to be the opposite of what it would normally be. Normally that would be a -1.5, so the opposite of that -1.5 means that this one is going to be positive. That's a tricky part right there. And then for -4, we're measuring an integral starting here at 1 and going all the way backwards to -4. So looking at it normally, we would take a -1.5 and add a 2 to that and get a +2 for the value of that integral. But since once again the limits of integration are going to be backwards, that positive 0.5 is going to flip now to a -0.5. And that's going to go there. So it turns out we actually were able to figure out the values of all four of those integrals. So, as they wanted them in order from least to greatest, it looks like our lowest value comes from g of -4, followed then by the value of g of 1, which was 0, which in turn is less than the value of g of -2, which was 1.5, which is less than the value of g of 5, which is going to be 2. So if we look at all of the choices here, in that spot right there, g of negative 4, followed by g of 1, g of negative 2, g of 5, and it looks like A is going to be the answer to this one.